Okay, so now let's look at some of the homework I assigned. This time we're actually doing the opposite. What we're given is the derivative, and we want to find a function so that when we take its derivative, we get this. So what we end up having is the sine cubed of t dt, but then we want this value to be 0 when x is 5. So that means that we integrate from 5 to x. For 22, we want a function in this form so that when we take its derivative, we get e to the x tangent of x. So that would be e to the t tangent of t dt. And we want y to be 0 when x is 5. So that would be from 5 to x. Now, I noticed that I made a mistake. This should have been 8. And so this would be 8. So y is 0 when x is 8, because from 8 to 8 would give you 0. Now, in number 23, it's the same thing. This is going to be the ln of the sine of t plus 5 dt. However, if we start integrating at 2, then the integral from 2 to 2 would be 0. But we can adjust that by making our constant equal to 3. For 24, this is going to be the square root of 3 minus cosine of t dt. And then we're going to start at -3. But when you integrate from -3, you get 0. So then we just make our constant equal to 4. And now when you take the derivative of this, you're going to get square root of 3 minus cosine x, and the derivative of 4 is 0. Okay, last two then. For 25, this is going to be the cosine squared of 5t dt. We're going to start at 7. And if you integrate from 7 to 7, you get 0. And so we correct that by making our constant -2. (26) is going to be e to the square root of t dt when x is 0. So we're going to start from 0 to 0. And then what we end up with is plus 1. Plus 1. There you go, plus 1. Okay. All right. Well, feel free to pause them at any time and try a few on your own, and then you can just check to see if you have them right.